Hello, everybody. And I'm checking if this is working. Looks like it's not changing the slides, so I will stand there. I would like to welcome you on my session, Medalion Architecture. We'll try to decode this in practice. My name is Wojciech Bukowski, and I'm a data architect and a data consultant, and also a bit of an engineer still. And I would like to also invite you to visit my and Adrian Chodkowski blog SQLity.net. And today's we're gonna talk about, hype kind of a architecture pattern. I will try to show you some theory before I jump to the examples. And before we jump to those bronze, silver, gold stuff, I want to remind some of you and introduce for others some base definition and how I understand that. This is my understanding. So if you find something different on the internet, it's everybody's writing about it. So what's the data lakehouse? So data lakehouse is fundament for Medalion architecture. Yeah, this is a data management architecture pattern where it incorporates both benefits of a data lake. So managing unstructured and semi-structured data, something we didn't have in a data warehouse, and incorporate also the benefits of a data warehouse when you basically manage structured data. You had ACID compliance, you had the transactions, you have a data modeling patterns. So this goes also with a system. So vendors like Databricks or Fabric, you build this lakehouse on the top of this technology. And this system, like Microsoft Fabric, for example, should allow multiple teams to cooperate in one platform. Yeah, so you have data engineering initiatives like streaming. You can have data scientist initiatives. So you don't have multiple interfaces between the systems. You put everybody in one system, one interface, one APIs, and they cooperate on this platform. So that's my understanding of a lakehouse. And please mind, and this helped me a lot, that if you are coming from the data warehousing, understand that data lakehouse is evolution of a data lake, not evolution of the data warehouse. They adopted data warehouse into the data lake-ish platform. So yeah, data warehouse is adopted there. Yeah, it's sexy, it's business specific. So you're working on the files, not on the databases. They're usually on the lakehouses. So what's the Medalion architecture? This is not a ETL pattern for you. They are not telling you how to do the ETL. The people that invented the Medalion, like Databricks. This is data management design pattern. So it's logically organize your lakehouse into the layers. Usually they split it to the bronze, silver, gold. This is not written in a stone. This can be A, B, and C. This can be 1, 2, 3, conform, clean, and so on. Yeah. So however you name it. And sometimes people refer it to the multi-hop architecture because in each layer you usually keep as much data as possible because storage is cheap. So you have 1 gigabyte data in a bronze, then you multiply this data over the layers. So there is a lot of data redundancy, and it's okay. It's supposed to be in this way. Yeah, it's there is also this paradigm that you improve the data quality as the layers goes, and it's very hard to in all the cases follow just this paradigm that you just improve the quality. Yeah, when we implement that, we don't necessarily follow just focusing on the quality. We focus sometimes on checkpointing and so on. So what is exactly a layer inside this Medalion architecture? So layer is like a materialization step of your ETL process. So you materialize data in the bronze, you materialize data in the silver. So in this definition, can we consider view as a layer? I say no, and a lot of you will argue about that. I said it helps us to organize stuff in a lakehouse. I will show you how to use a view, but I call view like an interface because view was probably never executed. Somebody implemented, never tested. So how you can prove it's working? Yeah, so it's not exactly a layer. It's more like an interface. And how it's very confusing for people. I install Databricks, I install Fabric. I don't have like a Medalion architecture there. So how we represent that in the architecture design? We represent that by the prefix or a suffix of an object. You have a gold fact sales, and it's layer. It's fine. Yeah. So in a Databricks you have a table, schema, and catalog. In a Fabric you have Lakehouse, workspace, table, warehouse. So you have a certain naming. You have to follow certain naming convention in your organization. So basically you can name an object. If you name a catalog or a workspace in a Fabric, gold, everything here is gold. I find a better solution than naming. I find very nice. I don't know if Fabric got that, but Databricks got it. It's tagging. You can tag an object. It's a gold. You can give a table of properties. It's gold. And it's also fine. That's how you do it. So you install, Fabric, and you don't have like a Lakehouse that is gold because maybe your solution design is different. Yeah. You can follow some accelerator. They show you how you can do it, but you have to design in your organization how to do that. So what exactly is the reason for having a layers? So layer give us possibility to have a recovery point in a data processing pipeline. Basically, I can finish here. Yeah, that's it. That's the most important from the ETL perspective, that you have those checkpoints. It's decomposite the ETL process to the single, like small steps. Yeah, if you have 5 layers, because why not? You have 5 recovery points. It gives you a so the next thing, it gives you a reusability of the layers by different teams. So if you build a silver layer and multiple teams can use that, that's the benefit of a layer. So you put more, you put a certain transformation in a certain layer for people to reuse it. Yeah, not build a monolith. You split also the technical transformation that you used to do in a data lake versus the business transformation that you did in a data warehousing. So bronze, technical, gold, business. It's also create a full trace. It helps you to trace the changes as the data flows. Yeah, so if you have multiple layers, you got those checkpoints, you know that you execute transformation A, you know how the data looks before and after. So that also helps. And it has to give you a possibility to limit hitting the source system. Yeah, so you want to dump everything to the first layer, not to query the source system again. And you can also use that for the data archiving and debugging process of your ETL code. It helps basically to debug rather than having a monolith. So what's the reason of entire Medallion? So all those layers. So there are 2 reasons, in my opinion. First reason is a business reason, that you helps company to understand when you let somebody into the bronze, and I don't allow almost anybody to the bronze other than engineers. So if you allow people to the bronze, they need to expect duplicate data, test data. So have you ever heard about having in a production test order, test customer? I always have those examples, yeah? In a silver, I clean it. In bronze, you have it. Expect that. You'll not have a perfect data there. And for the engineering team, and this is my responsibility usually, I said, this requirement go to this layer, to pipeline between bronze and silver. And for all of us, if we follow certain pattern, it's easy when you switch a project or switch a company that you have a common pattern of doing the data lakehouse or ETL process. So what's the definition of each layer? And I find this, I was doing a cryptocurrency some time ago, and when I watch some guys on the YouTube, they say, this information you will hear about is not financial advice. You need to make your own advice and then advise you to buy a Bitcoin, yeah? Right now, and it's go down and they don't have a responsibility, yeah? And in the internet, you have a lot of different things about the Lakehouse. And what I will show you is my definition. You can take an inspiration from that, and it was done successfully in a couple of organizations. I cannot name it. But before I jump to the gold, silver, bronze, let's make a sneak peek what some of you did already. You have a classic data, like a classic SQL server where you implemented a data warehouse or some reporting system. So you have layers, like you stage the data in a stage schema. You make a third normal form or ODS layer. Then you create a data warehouse, enterprise data warehouse, or directly you create a marts or something like that. So it's like a more or less bronze, silver, gold for you. So you already did that. You checkpoint the data in a layer. So you more or less now understand what we'll be talking about, yeah? If we, in addition to that, add one more layer, because we are talking about unstructured data, semi-structured data, so it's very hard to not error-prone insert something to the SQL Server. If you put something to the data lake storage, for example, Data Factory got a staging capabilities that automatically put the stuff to the storage before. So that's the raw layer. Additional layer we'll be talking about today. And I found this pattern and I start implementing that in the companies, that I talking about the rules. When I design the layers in organization, I'm talking about the rules. What are those rules? This is a company-wide kind of a contract. And in this contract, you say, what is the naming of a layer? How we implement it is certain with vendor. Do we name something gold? Maybe we name something curated. And we add the prefix to each table. And that's something you need to make company-wise. And also, you say what is allowed and what is not allowed in each layer. If you create a set of those rules that will jump in a second, I think your medallion will be successful. And those two things we talk about are business and engineering rules, or at least a kind of a documentation on a wiki page or something like that. And we will focus more on the engineering stuff. So what is allowed from the technical standpoint on each layer. So those are universal rules, yeah? So first rule is that applies for all layers, for entire medallion. So technical transformation also always goes to the lower layer than in a higher. If you convert the Unix timestamp to the basic timestamp human readable, it's not gold. If you're doing that transformation in a gold layer, you made it wrong. Do not create sublayers. I see people are not comfortable with bronze, silver, gold, so creating silver 1, silver 2, silver 2.1, silver 2.2.2, and then people are confused. What to expect in this layer? Do this transformation go to the 3.7? Yeah, okay, let's implement that. Create a layer. Make a, I don't know, color yellow before gold maybe, or something like that. Create pick any color, pick any name, create this layer, create a rule, implement that. Have a 7 layer if you need. Then lower layer, focus on avoiding error-prone transformation. It has to load data to the first layer on whatever the reason. Make it in a way it do not fail to avoid going back to the source system. Dump it, like in data lake. Higher transformation should throw you an error warning or stage some data with possible error if you might have quality of your data compromise. That's basically golden rule. You can have this rule also for silver, for example, yeah, and also fine. If multiple team reuse a certain transformation, it's candidate for the lower layer rather than the highest layer. So if people building 10 data mars based on your silver and doing a certain lookup, do it in a silver, yeah? And that's your rule, yeah? And exceptions happen all of the time. You have the, I don't know, data warehousing initiatives in your Lakehouse, then you have a new initiative, you redefine bronze, yeah? And that's happened. You can redefine rules for one subset of a bronze. Right? You have multiple instances of a bronze, for example, source system orientated. So exceptions happen. And it's better to fix your rules rather try to fit into a wrong design pattern. And I see in every single project I saw it. People say, this is silver, I have to put it there. Then you create a monolith and very error-prone transformations. And do not skip the layers. We'll have an example of how not to skip the layers. So, okay, we go to the layer-specific rule. Raw layer, this additional layer that a lot of people talking about now. So first of all, data in this layer is unprocessed. If it's JSON, it's JSON. If it's PDF, it's PDF. Next, one file format per one container folder. So you always start, physical implementation that you name the folder, I don't know, CSV, and everything inside this folder is CSV. It's much easier than to work on your ETL process. So implement Hive style partitioning. This is basically saying that you say first like a key value per. So key is a system and value is SAP. You'll see a lot of benefits when start playing with a Spark, for example. It's basically automatically taking this value as a column and this value as a value of this column. Automatically, you don't have to take care about this. Then you need to have a consistent date-time partitioning naming. So basically you say this is your kind of naming. And it's important because you will probably end up with those columns to be part of your table. It cannot overlap with the source system. So also that gives you a possibility to automatically load the data incrementally because you don't have to care about the things inside the folder. If people, external vendor put you A, B, C, E, F, G files, it doesn't have to be, incrementally named because you implement good Hive style partitioning. So if they are multiple files per minute, so implements a seconds as a partitions. So you create storage. So data you keep here, you make it only system-to-system communication. You don't let people sneak peek in your production raw layer. And I heard in today's conference that people have, those budget files that need to be loaded to the gold. Make it a raw layer. So create a folder in dedicated, file system and have dedicated structure for it and let people upload the Excel files. Why not? It's Lakehouse. It will ingest also Excel files. There is perfect design in here. I designed this one time and I'm very proud of this kind of design in a raw layer. So you enrich that kind of a data layer to your metadata kind of orchestration layer. So if you have CSV files, you don't know the schema, so you expect source system to put a schema into the folder and you can automate everything. Then you have operational folders where you put a JSON. I like JSONs in this way, where people say, I reloaded the data, expect full reload, expect 500 records inside my CSV. It's not 500, you have the data quality baseline, yeah? So you can make your life easier. Okay, bronze. So raw layer is supposed to be, temporary layer. I find it's better because of some GDPR reasons that we'll jump in a second. So here bronze is basically like you put data into the common data format that is a Delta Lake for Databricks and a Fabric at least. I don't want to go to the different file formats, but let's say it's Delta Lake as a first possible choice. So this rule applies for all layers above bronze and above. And data should be structure checked. So schema validated. So you validate, you parse the one row. So this is ruling here, for example, that if you have stuff like a JSON file, it's a not nested file, or it's nested, you just extract first layer and make it tabular. I see people don't follow this rule and keep JSON in a single column, and it's also fine, yeah? You can quit this rule. I allow people doing that because I have a raw layer. So any data source can be there, yeah? Any kind of structured data like CDC, batch, or streaming. There could be image metadata in your bronze pointing you to the storage location of an image. It can be binary data. You can transform XLS to binary file, load it, and do something with it later. It can be picture in a binary format. Delta can consume that, so that's okay. So this is you need to enrich your data with some metadata loading layer, like columns. So like timestamp of a load of file, name of the file, partition of a file, and so on. So you know what you loaded and what you did not load from the raw. And you keep history forever, or at least as long as possible. You never truncate it. You never touch it. If you want, you can leave data in the bronze and decide what to do it later with that data. In the next layer, in a silver layer, don't do the historization unless business asks you to do, because in a bronze, you can recreate slowly changing dimension or a snapshotting from the bronze anytime you need. So keep that data forever unless GDPR people will go and only 3 years. Oh man, I cannot keep it forever. And always keep all the columns from the source and implement schema evolution. as the schema change on a source, it change automatically on a bronze. No exceptions there. It has to be in this way. No business logic. Somebody is coming, just technical transformation. Make it super non-error prone. You expect, you load, dump everything, even it's garbage, even it's a different schema. You need to design it in this way. It's append only. It's append only. No update, no delete. For pipeline loading the bronze, if you have GDPR regulation, when you need to delete some data, so you need to implement separate pipeline. Somebody is going delete Wojciech Bukowski data from all the layers. So you have a pipeline deleting it from the bronze, silver, and gold, entire lakehouse. But normally this is append only. Otherwise, the next layer will fail. I guarantee you. So then we are going a little bit more into the business requirements. So I think the most important is a first point, and we can leave the rules like with a first point. Validation and equality. So including the data reconciliation. It's very source-orientated layer, in my opinion. It's almost one-to-one. At a certain point of time, you can have one-to-one data in this layer if you don't implement historization in this layer. So implement validation and equality rule. And without it, you don't have a silver, in my opinion. If you have a garbage data in the silver, it's not a silver. So those operations are allowed: merge, append, override. Full load, merge, so deduplicate data, or append. If you have a streaming data, for example, it's append, yeah? Joins are allowed, so you can join. You should avoid joins in a silver unless this is a master data or a dictionaries, because people will reuse it heavily. So you have like a country ID, 1, 2, 3, nobody understands that. I know, look up it. Everybody will look up it in the gold. So this is read access only by qualified personnel. Do not let business people in here, because what they will do, they will say, give me row level security here. How design row level security on a silver layer? Exactly as in SAP system. And you spend 5 years implementing row level security on a silver layer to replicate SAP row level security. It doesn't make sense. Make security on the object level. You have a sales table from Germany, for example. That's your security level. And there are two approaches. I go with approach only required columns, but people go with all columns from the bronze. Why I go with only required columns? Not to have a lot of data redundancy. Because people unpack from the streaming data, I don't know, thousands of a column and use only 5 later. And you have like petabytes of data in your lakehouse because of that. Optimize write instead of read if not possible for both. This layer do a lot of merge, in my opinion, so I optimize for write. And there is a very hot topic, conforming the data. How I understand the conforming data in this situation. When you have multiple systems talking about the same thing, like a customer, you have Oracle, SAP, and the different databases, different sources talking about the customer, people tend to conform data in the silver layer. So say we have one table for a customer. It's not source system orientated then. It's a lot of business logic in here. You have to concatenate field. You have to think about entire silver. Rather split, if you are thinking about conforming data as a silver, I would go with 2 different layers. Or people do the conforming data like in the gold layer as a dimension, yeah? To have one customer dimension for everybody to reuse. So this is something to discuss. If you implement conforming a data here, that's basically mean you lose possibility to automate everything up to the silver, in my opinion. So that's your decision. So in gold, it's tricky because there will be multiple instances of a gold. Because gold will have a role specific to your initiatives very often. So you have machine learning initiatives. So in your gold, you will have a feature store table. So table with primary key and a lot of decimal columns. You have like logistic mart, and you'll say, okay, so this is data mart rule, we'll implement star schema. There, I know, there could be really a lot of different initiatives. So you say, okay, we'll have data warehousing initiatives, yeah? So implement that rule there. So for example, you say, okay, we do usually what we do in a gold is a data aggregation, dimensional modeling, flat big table, structure, for some operational reporting, for some raw single row lookups, for example, even flat raw data optimized for read. Sometimes we take data from this gold, and as if you've been in a James session, people move it to the SQL Server or Cosmos DB, for example, for lookups. Yeah. So that's why we are, let's say, allowing. We optimize for querying. We do the schema enforcement. So up to silver, we could have a schema evolution. Here, we don't have a schema evolution. Schema go first. You design schema. You implement the table to the Lakehouse. When you load the data, it should fail when it do not match the schema. Yeah, somebody make a mistake doing the ETL process. If you don't do that, you know, next layer is Power BI. You cannot make it. There will be, you know, next day it will be different schema, and business people will be angry. Row level security is welcome here. So this is the layer where you implement the row level security. And it's not super source aligned. So don't try to replicate, you know, source system row level security, because you will not be able to. Just, you know, regular, like you say, this person should be able to see that country, and that's okay. You can also implement the row level security on a kind of semantic model Power BI layer, and that's okay. You just make this layer to be available for a Power BI. But you can do this row level security here. But there is something that is very worth to remember, in my opinion, about each layer. So first thing about the raw layer, it's optional layer only when your extraction system can load directly to the Delta, like streaming analytics. It can do Delta. So why bothering with a raw? If you can extract directly from IoT systems, for example, to the Delta. Data Factory do not know the Delta. Like, it knows how to write the Delta through the Databricks, but it's not basically Databricks loading the Delta. So if you have Data Factory loading things and it's, I don't know, ask REST API for something, dump the JSON, that's okay. Don't bother doing the Delta immediately. Raw layer is not like evil. And I see people like doing, oh my God, bronze is, people then switch, like bronze is a raw, and in a raw then you have a JSONs, Excels, and Delta, and it's very confusing. So that's, I think raw is a very nice feature to have in your Lakehouse. So then in a bronze, why we do the Delta? I mentioned to you that we need ACID compliant. We cannot make partial load, like load 5 files out of the 6 and whatever. We want to use something that is called data streaming, and we discuss about the GDPR cases. We don't want to look up 15 terabytes of a data. We got data in, let's say, structure way, and we can look up single files and delete some data with transactional guarantees. And it's if source system give us a full load every day, there is exception for, you know, keep all the data forever, because you want to limit the retention period. I saw people loading every day 100 gigabytes of a data and keeping that forever. So I don't know what was the use case. Nobody could answer me that. And do the select star and do the schema evolution. So in a silver layer, if you need to define common pattern for schema evolution. You need to learn about schema evolution, how to do that, and do that in the same way every layer. So that's very important to have it structured in the same way. If you decide to load all the columns from the bronze, consider it cost. If you allow the join operation, document that for each case. Not to create a situation when one team is, for example, saying what's supposed to be in a silver, and you suddenly end up with a silver being gold, and you end up with no intermediate layer. So keep, what I do, I keep source system column names as it is for me to easier debug or reconcile it with the source system. Instead, I'm doing the views, and the views are basically like this interface where I implement the friendly column name. And that's working perfectly fine. In a gold layer, as I mentioned, this can be everything. If you say you have initiatives of a data mart, as I mentioned, you say, okay, always create surrogate key. Always do the star schema. Never do the snowflake schema. Do the single day dimension. That can be your rule, yeah? If you have that initiatives. If you have machine learning initiatives, your rule will be different. And don't copy that rule if you have machine learning initiatives, because nobody will be doing the data mart in your Lakehouse. That's waste of your time. I mean, you can copy that, but There is also, if you follow, the Lakehouse is usually done for big data initiatives or for big companies and so on. And I encourage you to do something called metadata driven. So in those two layers, aim for ETL to be metadata driven. Aim for data quality rules to be metadata driven. And define those rules in one place. What does it mean metadata driven? You have like SQL Server. In SQL Server, you have some, I don't know, tables to load, primary keys, this column from unique timestamp to timestamp. ETL can consume that and automatically apply during the fly. Also for quality rules, you do the same. You keep it in the SQL Server. Then somebody can build the application on top of your SQL Server and create an application for defining the rules in a big organization. So make it metadata driven. Don't hard code it. Don't put it into the, directly to the Fabric notebook or, Databricks notebook, because nobody will dig into your notebook and check your quality rules. And you can automate that. Basically adding new table, adding schema evolution, changing some, stuff. You, execute one stored procedure in your database and your entire ETL change. It's metadata driven. Make sure any reload in those layers can help you avoid reloading the gold layer. So gold layer, so loading fact tables, reloading fact tables that is 1 terabyte big. How big of a hassle is it? Pretty big. If you have problems in the silver with a quality and you're reloading from the source terabyte of a data, you can match every single key and the value and see what exactly changed and not, and make the next layer to not have such a big load. So if 15 golds is loading from your silver, make it possible they load only the increment, even if you reload the silver for some reason, because your data was compromised. And make sure you build some kind of subscription model to your data consumer. So a lot of people will be consuming this silver in a big organization. In a Databricks, for example, this change data feed. People can read, changes anytime they want when you implement that. Snowflake got also nice features as for subscription model for your silver. So people subscribe and consume whenever they need the silver. And you need to make entire, security in a way that you can very easily let people access their object. So there are a lot of questions. One was on, I think, on the application. Are there only 3 layers per plus raw? Do we have only data layers? If we have machine learning initiatives, what are the different standards? So if you go to some blog posts, you will see semantic model is also a layer. In your entire solution design, DAX statements that need to calculate on the fly and cannot calculate and materialize is your layer. And it's okay to put it in a diagram. Don't be, I have a Lakehouse. We got a semantic model, it's not a layer, yeah? When you do the import mode, it's a layer, it's physical layer, it's materialization step, yeah? If you have machine learning initiatives, you will have machine learning models. This is artifact, you have to place it there. Maybe make a place in your, workspace, in a Fabric or in a Unity catalog, in a Databricks. You will have machine learning scorings. So those models will score something and save it in a Lakehouse, make a space for it if you have that initiatives. And maybe for your initiatives, you will have like a ML scoring layer. Call it like that. Don't call it like a bronze or gold, yeah, because people will not understand what's inside. So if you go to the advanced analytics and you type in the Google hype about Medalion, I find it's too late. And I find it very nice saying that basically, we have this raw file, we have then bronze. So basically this is raw, I don't call it bronze. You have a schema validation here. You have cleaning data and validation. You have conforming a data, and Simon said it's silver, but it's not same silver. You have gold as analytical model and reporting model, so basically a semantic model. So he does that, and if it works for him and for organization when he implements that, that's fine. This Medalion is for you, not for the guys who's writing the blog like me. So you have to make a decision in your solution design, and you have to deal with the consequences. So you can implement one layer. If it's fine for you, it's fine for me. If you implement 15 layers, if it's fine for you, an organization, it's fine for me. So those are things you need to consider, like the time to deliver the report. If you go through the 15 materialization steps, layers, you will end up loading 1 gigabytes data in 3 days. Yeah, wow, you got 15 checkpoints. But yeah, it's delayed. Yeah, this is not how you build a Kappa architecture, for example. There will be a lot of data redundancy. Cost of the storage can be huge if your organization have terabytes of data. What is the level of your ETL modularity? Yeah, how modular it need to be. If you have a lot of complex transformation between layers, maybe it's worth splitting gold into two golds. Yeah, like enterprise data warehouse and the data mart. That's also, you can make that layer, separate layer. What's the time to recover from the crash? If you have load everything from the bronze to the fact table, oh man, you're screwed. But if you have to load it from the silver, it's a little bit better, yeah? So make a decision. What's the cost of the recovery? Maybe cost of the storage is so high that it's better to run the compute very, very big cluster and reload something in 30 minutes, yeah? And the cost can be cheaper. What's the time to debug an error? If somebody say your data is wrong, how long it takes? It's better to do it from the silver rather than from bronze. How easy is for the business to understand what is inside the layer? So name it, document it. How easy it is. If you do 5 layer and it's much easier for the business, and have it in mind, you're doing that for the business, not for the ETL developer, yeah? So make it easy for them. Okay, let's go to the examples. I will click a lot of spacebar, so I'll have to stand there. So this is the basic way of going through the layers. So in a raw layer, somebody from some kind of a system is sending you a JSON file, or I load the JSON file. I call the REST API and dump to the JSON file to like a sales order 2023-03. Don't look at that. That's wrong Hive style partitioning. Yeah, there should be year equal to 2023, month equal to 03, and so on. And that comes in, this table is represented by this kind of a JSON. And you land that to the raw. What you do the next, you basically have 3 JSON files that you need to incrementally append to your bronze table. So you have one physical table in your Lakehouse, and you append that, and you enrich that with metadata of a file name, load date, load by, load ID. I see people doing overcrafting and having 3 columns as a data and 15 as a metadata. Yeah. And it's bronze and in delta. So then you take that bronze table and you say, okay, they allow me on a SQL day for technical transformation, deduplicating the data, so removing the duplicates. I'm not doing the historization, so I need to have the most recent record only, so you're doing the duplication. And they allow some kind of the transformation, so I can but I don't have to look up this value in the dictionary and in the master data. And there is star, you have to document it when you implement that. And that's basically a silver. So you transform this date to like date, human readable date. You deduplicate data, so you have like a order ID replicated here 923, 923, 923. You end up with a 1 order 923 in the table. So, sorry, I'm supposed to talk about OID, that's the order ID. So, yep. So then you end up with, multiple tables in a silver layer, like that. And you create a gold layer. So in the gold layer, we do the data modeling, you create the calculations, you do the business measures in here, and you materialize that in a dimension and a fact table. This is the easiest example, and I did many times, and it's looked like regular data warehouse, yeah? Maybe stage is permanent, and that's all. So if you look in the more complex cases, when you're dealing with like event streams, you have different events every single line. So you expect different JSON in a one single column called parameters or body. You have to decomposite this, and you can end up with one bronze, resulting in my case, it was 1,500 silver tables, because you have a different event type, and you need to parse this JSON, and you need to take some of those values in here that will be used as a bridge, as a key later, and you have to parse it and save it as a clean, validated, tabular, human-readable tables. Next thing is like a binary data. If you load the data from the Event Hub or from the Kafka, you have a binary thing in the body. Whatever it is, you load it in the bronze. It's not error prone. Then you basically parse this body to the JSON. Then the JSON parse you to the table. You're dealing with the streaming, so you want to capture a time window of like 15 minutes and calculate average humidity in each country every 15 minutes. That's an example of bronze silver. In a bronze, you can load the images, and in a content, you will have binary representation of the picture that you can reuse for machine learning. And you can even display it in a Fabric and a Databricks. It will display. It will know its image and it will display it. In a gold layer, you have these feature store initiatives, for example. So it will be ID, maybe the time series, and a lot of columns that is just a decimal. And one of the rules can be, it has to be decimals, because pandas consume just the decimals. They do not consume the floats. So common mistakes in Medallion. So layer skipping. I saw it like 15 times. People say, I want my data warehouse data to be available in a Lakehouse, because I have streaming data, IoT data, and I want to use data warehouse data in my Lakehouse. And I don't want to redo the warehouse inside the Lakehouse. So people look at that. This is dimension. Dimension is supposed to be in a gold. So what people do, they create mechanism that load this directly to the gold. If they are nice, they stage it in a bronze, because they need to have incremental mechanism that can take duplicates, load it into bronze, deduplicate, and load it to the gold. Who tell you that this is correct? Maybe somebody say, we need to validate the data. Maybe there is plan to move that later to your medallion. What I do, I say, load the increment to the bronze. Maybe you will have schema evolution. Maybe your people don't like schema evolution in your Lakehouse, but like it here for some reason. And make it clean in a silver. If people will be confused that you have dimensions in a silver, create a view and place it in a gold. You don't skip the layer. And basically those transformations that happened in here, you're not doing dimensional modeling. You're just deduplicating and validating if your dimension that comes from the data warehousing system is correct or not. So next mistake is that, we briefly talk about that. There is full load of 1 terabyte data from the source every day. So in a bronze, you end up every day loading 1 terabyte of a data. After 300 load, you load 300 terabytes of a data. And this is because you read that in a blog or heard from me, and you stick with that rule. What benefits for a company gives you to keep 300 terabytes of some streaming event data? That somebody is happy on a Twitter, for example. I don't know. For me, it's nothing, yeah? But what you're doing, then you're doing the next wrong pattern. You make this not error prone. So you do full load on the silver. And you basically, that's okay for the, IT stuff. And you read 1 terabyte from the bronze, you write 1 terabyte to the silver, so people on the gold have to read 1 terabyte of the data. And how to improve that? That's very important for you, archive those data to the archive tier on the storage. It costs pennies compared to the hot storage on the blob. I know it's very technical, but you can archive whatever is not a current snapshot. You can archive that. It's very important for you. If not, you can delete that. It's okay. You make an exception, you could document that, and you do that. Then you don't read and write 1 terabyte. You read 1 terabyte and you write to the silver 1 gigabytes. You can compare, as I mentioned, key to key and all the values to all the values. There is like a technique that is creating hash from keys and hash from values. I encourage you to read that. And you let those pure gold people read only 1 gigabyte of a data. And that's correct pattern. And the last mistake is lack of solution design. People go and say, bronze, silver, gold, install Fabric, fabric.exe, or Lakehouse on databricks.exe. It comes with some default. So people create, for example, in Fabric, one workspace, one Lakehouse, dump everything, no naming, no solution design. They say bronze, silver, gold, but this is not even an initiative that requires a layer, because I install Fabric, I need to do the Lakehouse. Or for example, in Databricks, they do the Unity catalog and land everything to the Metastore storage. If you have 100 terabytes of a data, keeping things in a one storage, for example, will create throttling. That is basically one storage will not be capable of, reading and writing the data. If you split that to the 15 storage, then it's better. And remember, you'll have multiple instances of a bronze and a silver and a gold, yeah? If you have system-orientated bronze and silver, you will have, for example, 15 sources and 15 instances of a silver. If you have a requirement of, I don't know, data regionalization, for example, you need to consider that. So make 100 instances of a bronze, but also understand the limitation of each vendor, that you cannot have, for example, thousands of workspaces of 1,000 lakehouses, for example. So make sure you have a solution design. And we'll jump in a second to the solution design. So what's the implementation design? So this is what I mentioned. In the internet, you have hundreds of a blog post because it's a hype for the lakehouse. Don't copy paste what is there. You have to make your own solution design, take inspiration, because inspiration are good. You can take inspiration from this presentation and build your own lakehouse. Even if it will work one-to-one, you need to understand the content of it. So then be driven by the project requirements in your organization. There are a lot of things that I do consider, like what's the goal for the project, what will be the access control, who will be the data recipients, do the data have to be split physically, what is the cost tracking requirements. For example, one architect asked us to design it in a way that each source system will pay what they load to the lakehouse and transform. So you'll have to, redesign it in a way that it's easy to track the cost in Azure, for example, by tagging, creating multiple workspace storages, and so on. How many environments there will be? Yeah, we talk about only like a production concepts so far, but you remember you'll have 4 environments, for example. Do we centralize some data layers, or do we decentralize? We often say we centralize bronze and the silver and decentralize the gold, and we design it this way. And a lot of companies agree that. Or maybe they go with data mesh. Sorry. So technology should not. So if you pick technology, don't feel that you have to build a medallion. If somebody asks you to install a Fabric, so log into the Fabric, to SaaS solution, and say, I want Power BI report that's on a real time connects to some events and display it on a real time on the Power BI. That's your requirement. You go, say, Fabric, it's Medallion, bronze, silver, gold. I will load this to the bronze, deduplicate, validate it. It's not real time anymore, You load it through the 3 layers suddenly, because you are so fixed about, building a medallion. So having a Fabric do not force you to build a medallion. Having a Databricks do not force you that. It's nice pattern doing, kind of a step-by-step ETL. So in a Lambda architecture, for example, you load the stuff directly to the, for example, Power BI model and display it, but you also, second pipeline is loading to the bronze for the further analytics. And you do the medallion. But is that your requirement that you need to save it and persist it forever? If it's not business requirement. Don't do the medallion. Don't bother that. I see people, want to install Fabric, have a medallion, and then do the project in that way. So I want to just showcase you, some implementation design. I find this slide, nice and sexy, yeah? So I paste it here. It's not my design, but, it showcases you how people do medallions in a fabric. So I see people put there this raw layer as, storage, then do the shortcut to the fabric. They orchestrate entire process through those pipelines inside the fabric or data factory. They ingest the data to the Lakehouse, and they do the Lakehouse for all the bronze and the silver layers. You see the silver layer. I think somebody make a mistake with the naming. It should have some certain name. Even silver 1 and 2 will work in this way. And they have these warehouse capabilities and keep gold layers in a warehouse. And there are also like 2 golds, and that's fine. As I mentioned, if that fits the business purposes, if that is how it looks in a practice, it's okay to have that. Just go with a better naming in here. And there are some rules in here, as you see. What do you do there? What do you expect from the layer? What I do the most of the time, because I'm still beginner at the fabric, I usually do it in a Databricks, and I orchestrate entire process through the data factory. So even I execute jobs in the Databricks. I even from the Azure Data Factory ask nicely Power BI to refresh semantic model. And I do multiple instances of a Databricks. I keep every single layer in a single storage or container inside the storage. I use the Data Factory for batch loading. I use the Azure Event Hub or Kafka for streaming or events, and then I load the data. As you can see, sometimes I'm moving directly in here. For example, inside the gold layer, I'm creating a live layers, and I'm I'm saying the live layer is not part of a medallion, but it's still in a one architecture design for this, Lambda Kappa thingies. And as you can see here, on the same time, I do load these events into the first layer and doing bronze, silver, and the gold. So there are some stuff that you need to, this is lesson learned. This is how I design usually bronze and a silver in Unity catalog in the Databricks. So I go with the naming that I name the catalog bronze, then I name the schema as source system, and I keep the tables inside it, and same for the silver. Or I do source system first and the bronze and the silver inside the schema. I use this or this pattern. Sometimes one is easier for me for manage access control. Just that. And that works really well. And you don't, and Databricks do not recommend, for example, that pattern. One project with data warehouse and machine learning platforms. Those are 2 designs I made. And I believe we use this one. So first we say, what's the core initiatives? So what we expect in the catalog. So in this catalog, we'll have initiatives that follows the rules of doing dimensional modeling. So then I create like enterprise data warehouse schema, logistic mart, sales mart, and I prefix the tables, DIMs, and the facts. And then I have machine learning initiatives in a catalog, and inside this we have a fraud detection, client retention. Then we have the feature store table, scoring table, and machine learning artifacts in here. Or we do a little bit easier maybe to see from the high level. So we do the enterprise data warehouse, logistics smarts, machine learning frauds, and as you can see, we place there a table. So, you need to remember about the vendor limitations, because, for example, if you do more like structure where you have a lot of catalogs, in Unity catalog, you have a limitation of 500 catalogs. And I saw people doing, schema of a source system is equal to the catalog in here, and they end up with 500 catalogs within 2 months of a project, and they hit a limit. And Databricks said they will not extend that for them. So they have to do very big redesign of everything. And remember, you will have multiple environments, and you need to handle that. So how do you do that? Will you name workspaces like a dev test and a prod? So you will need to multiply sometimes number of the objects you create times the environments you have in your system. So if you have that in mind, you will not end up with doing a dev and cannot create prod after half year, for example. And this is a maybe reminder, because I briefly talk about it. It's that you have to keep in mind you might have requirement of data residentially. So keep data in a single Azure region, for example. And you need to consider backup and disaster recovery to replicate the data to the paired region. If you keep data in region in Azure that do not have pair, you need to implement your own backup strategy. So basically you say everything inside this catalog or schema need to be replicated in that region. And maybe SAP data comes from Germany, and Germany likes to keep data in Germany Azure region, and you have to consider that in your solution design. So basically that concludes my session. So hopefully it makes you a little bit clearer. The biggest highlight I want to mention is that this rule engine that I find it's very easy for organization to follow, because it forces you to create the documentation. And I think the documentation is the most important part of the Medallion, because then you know what to expect that. And I think within a year, I will be ready to stop naming things like gold, bronze, silver, and so on. And I will name things like SAP or fact sales and tag the objects probably. Because people don't understand this bronze, silver, gold and use that namings for something totally different, yeah, in organization. So, it's also the same thing. You will be very confused when playing with the data lake houses, because there is like a format data lake. There is a data lake house. There is a data lake. So, vendors make it easy for us to understand everything perfectly. So at least make sure you don't confuse the business users, and keep in mind that you're doing this not to be happy you did nice engineering job. You deliver a platform that can be usable by the business on every day. So thank you for the session. If you have any question, I'm there for next, I think 10-15 minutes. So come here, ask any question. How much time do we have still? 2 minutes? So yeah, we'll conclude here. Thank you very much.